Hello everyone, welcome to CSE 230 Discrete Mathematics. So now, today we are going to learn about quantifiers. So quantification is a method by which we can create a proposition from a propositional function. In the last lecture we saw that we can use predicates to create a proposition from a propositional function, and so there is another way. So this is quantification, and we know these words: all, many, none, few. These are used for quantification in English, but we are going to talk about two kinds of quantification: universal quantification and existential quantification in discrete mathematics. So universal quantifications of p of x, or we call this propositional function. So after quantification we will get a proposition, or simply we can write here statement or proposition, as it is another way to create proposition from a propositional function. So universal quantification of p of x is the proposition for all x in the domain px, for all x in the domain px, or px for all x in the domain. So, or we can simply tell this that p of x is true for all values of x in the domain. Okay. Now we denote this by this upside down a. This is called the universal quantifier. Universal quantifier. So when we write this means for all x p of x. So in the sentence we can write for all x p of x, or we can simply use the shorthand, this shorthand for all. This is the shorthand for all. Okay. We can also write this by some other terminology. So if you find in a sentence all of, for each, given any, for arbitrary, or for all, for every, these are all this can be written by this upside down a. Okay. So if we do an example, we can find how this turns into a proposition. So here all x q of x. Okay. Now say that qx be the statement x is less than 2. What is the truth value of the universal quantification? As this is a proposition, now this will have a truth value, obviously. So where the domain consists of all real numbers. Okay. Now if we can find only one counter example that can prove that this has a false value, then we can say that this is false, because we are saying here that for all x in the domain, q of x is true. But if we can find only one counter example, then we can say that this proposition has a false value. Okay. So if we put q3, this is an counter example, then if we put q3, then this will be x is less than 2 or 3 is less than 2, and this is false. So we can find many other values such as 4, 5, 6 and all others that are greater than 2. So of all those values, we just simply choose one here to prove that the quantification that for all x, q of x is true. This is not true. So we can write that. So for all x, q of x is false. Okay. So this is simply a proposition telling that for all x in the real number domain, domain x is less than 2, this is false. Okay. So let's move to another kind of quantifier, that is existential quantifier. So existential quantification of p of x is a proposition that tells that there exists an element x in the domain such that p of x. So if we can find only one element that proves that p of x is true, then this proposition will become true. So we write this in reversed e. This is the same as there exists. So there exists an element x in the domain such that p of x. So we can write this by, and this is a proposition. So if we can find only one example that is true for this proposition, then we can say that this proposition is true. So now we can find that in sentences we can find something like this. There is an x such that p of x. So this is also an existential quantification. Then also we can find something like this. There is at least one x such that p of x. So this is also existential quantification. Or we can see that for some x, p of x, this is also the same as this one. Okay. So if we do an example, we can find it easier. X, p. So let p of x denote that statement x is greater than 3. What is the truth value of the quantification for some x, p of x, where the universe of discourse consists of all numbers? Now look at this, universe of discourse, this is the same as domain. Okay. So let's find an if we can find only one example that makes this propositional function true, then we can say that this proposition will be true. So if x equals to 4, then p of 4 will be 4 is greater than 3. So there exists one element which is 4, and for this we can find that 4 is greater than 3. So we have found one single element. So if we can also put here 5 is greater than 3, 6 is greater than 3, and so on, but we do not need, we need only one example or only one element by which we can prove that x is greater than 3. And if we can prove it, we can say that there is at least one element for which this is true. So this means there is at least one x for which p of x. So this is true. As we have found one element which is 4, we can find out 6, 7, 8 and all others, but we need only one to say that this is true. And we have learned earlier that we have to find out only one counter example for the universal quantification, only one counter example, not example, counter example, which means that if we find only one element that can say that can create a false value of the propositional function q of x here, if we can find only one false value, for example here 3, so we found 3 which is less than 2, but here we are which is greater than 2 true, so here we will find that this is false. So this is called 3 will be a counter example. So for universal quantification, if we can find a counter example, we can say this is false. And for existential quantification, if we can find an example for which this is p of x is true, then we can say that the existential quantification of p of x is also